Okay. All right. So we have this, which is called a measure of variation. Okay. Basically here, what we're going to look at is we have a way of measuring how spread out the data is, meaning how spread out it is from the mean, how much variation there is. That's essentially what we're looking at here, how much variation the data has. Okay. And now there's really two ways of doing that. Well, I guess, yeah, there's the range. That's just the difference between the maximum value and the minimum value. I mean, that's useful, don't get me wrong. But a better way, as far as I know, to measure variation is to calculate what's called the standard deviation of a data set. So a better way is the standard deviation of a data set. Okay, now unfortunately, it is a little involved. Okay, it is a little involved. It's not terrible, but this is the process. First, you want to find the mean of the data set. Then, once you get the mean, you have to subtract it from each data value. So you subtract it from each data value. Then you square each of those differences, add up the squares, and now then you're going to divide by either n or n minus 1, where n is how many data values there are. You divide by n, the number of data values, if you have population data. But if you only have sample data, meaning data from a sample, then you divide by n minus 1. Why do you divide by different numbers like that? Honestly, I don't know. And then after that, you compute the square root of that quotient. And that's what the standard deviation is. Okay, the standard deviation, it will be a positive number, and the bigger it is, the more variation there is in the data set. In other words, the more spread out the data set is. So that's what happens here. All right. Just some notes here I wanted to point out. With the standard deviation, if you actually calculated the first 5 steps only, so you did not take the square root, then you actually have what's called the variance. That's actually what you have. So in other words, the standard deviation, if you were, squared, basically you're calculating it, but you don't take the square root, then you have what's called the variance. And just like before, you have population variance and sample variance. You can probably guess what the difference is. Population variance is for if your data is for the whole population. Sample variance, that's just, again, if the data is sample data. And it says here, number 3, let me get the laser thing, that we're going to assume any data set we have is sample data. That's really what the book does, so we're going to stick with that just to make it consistent. Okay? So in other words, with standard deviation, we're basically dividing by n minus 1, where n is how many data values there are. Because again, we're going to assume the data we have is sample data unless stated otherwise. What's nice about standard deviation, though, even though taking the square root can be kind of a pain, the units for it are the same as the units for the data set. The units for it are the same as the units for the data set. The variance, however, the units are squared. So like, for instance, if we did that data set where the number of hours SUNY Oneonta students read each week, how many hours, standard deviation of that data would be hours. The variance, however, would be hours squared. So that's one disadvantage to using the variance. I think the variance is easier to work with theoretically, but I could be wrong about that. Okay. So we did, okay, so let's do some examples. The first example I'm going to do with you, then the one after that, you're going to try it out on your own. So for instance, let's say we had this data set. I know it's sorted, but normally you don't have to sort it though for the standard deviation. You can, but you don't have to. And we're going to assume this is sample data. Now, first, you always want to calculate the mean. And again, you add up the data values, then you divide by how many there are, right? That's just the mean. So we add up these data values. There's 10 of them, so we divide by 10, which is 40 over 10, which is 4. So the mean here is 4. The mean here is 4. Okay, so here what I did was I listed the data values. I used the table to keep everything organized. I subtracted the mean, right, from each data value. So we have 1 minus 4, which is negative 3. There's 2 1s in here, so we do that as well. 2 minus 4 is negative 2. 4 minus 4 is 0. 4 minus 4 is 0, and so on. Okay. And then remember, we square each of these differences. Okay? We square each of these differences. Okay? That's what I'm doing here. Minus 3 squared is 9. Minus 2 squared is 4. 0 squared, of course, is just 0. Then what we do is this. We're going to add up all these data values, right? We add them all up, which in this case we get is 36. And remember, this is sample data, right? So with sample data, you divide by n minus 1, where n is the number of data values. In this case, n is 10, so we're going to divide by 9. And we end up getting 4. So the variance for this is 4, the sample variance. The sample standard deviation would be the square root of 4, which is 2. And that's what we have here. All right. Are there any questions on this? Okay. I mean, this one I figured I would let everyone try, although I'm wondering if we should because it's 11:43. Let's start it at least for like a minute, you know, calculate the mean at least. Take like a minute to do that. Actually, you know what? No, let's just do it together. All right. So here for the mean, right, you know, it's just like before, right? We're, again, assuming it's sample data. So we add up the data values here, right? We add them all up, as you can see. And then we divide by how many there are. It turns out there's 12 data values. So we get 90 over 12, which is 7.5. So our mean is 7.5. And then it's just like before, right? We have the data value, right? We have them. I put it all in the table. We do the data value minus the mean for each data value, as you can see. Okay. Some numbers will be negative here. That's okay. What they do next is they square the data values, okay? And that's what we're doing, right? As you can see, we're squaring. We square these differences, okay? Thank goodness we have a calculator. You probably could all do all this in Google Sheets. I think there might be actually a variance or standard deviation function, but you really should be used to doing these kind of calculations, at least with me in this class, because I like to see the work. So now if you were to add up all the entries here, okay, you add them all up, you would get 595. And this is sample data, right? There's 12 data values, so we're not going to divide by 12, we divide by 11, as you can see. And we end up getting this. So the variance is this. This is the sample variance. The sample standard deviation, though, would be this. So that's what happens in this example. All right, that's good. Are there any questions on this? And another example. Well, really didn't prepare this one. All right, so you know what? Why don't we stop here, I guess? So I guess we'll stop here. I mean, we do have less than 4 minutes. Oh, I guess less than 4 minutes left, but that's okay. Okay, so I'm going to stop the recording.